is our topic. Now we're going to discuss potential difference, PD, and electromotive force, e.m.f. Electromotive force, e.m.f. So now let us discuss. Let us see the movement. Let us see the movement. The movement of 1 coulomb of charge around the circuit. So this is our circuit. See, here is a source or a battery, source of power, a battery, and the charge is moving here. So here to meet with the resistor and resistor. So here in the resistor there is a voltmeter which will read 8 volts, and here is 4 volts. So we say that the total energy which is given by the source here is e.m.f, electromotive force. You see, here we are just talking about the energy. There's no meaning of this force, e.m.f. So it's just a total energy of, or the total power in the circuit, around the circuit, which is e.m.f. But the energy transferred, you see, when the 1 coulomb of charge meet with the resistor, it means there is energy lost here. Energy lost here because of this resistor. So that energy lost is what called PD. So PD, potential difference, happens in a resistor. So here there is a PD here and here. So the energy lost between the 2 points, for example, point here before it meets with the resistor and after the resistor. The energy before the resistor is different, is bigger than the energy after the resistor. It means there is energy lost in a resistor. So this is what called a potential difference. So the difference of e.m.f and PD is like this. So the voltmeter readings indicate energy transferred to the component by each unit of charge. So here it means, for example, here the energy here is 12 joule. The reading of voltmeter to give the energy joule. So here is 80 joule. You see, now the energy is lost because it is 4 joule. So the reading of voltmeter will give you the energy. The voltmeter placed across the resistor measure the potential difference. The voltmeters placed across the resistors measure the PD. So PD is used when charges lose energy by transferring electrical energy to other forms of energy in a component. So the potential difference between 2 points A and B is the energy. High unit charge. By unit charge, as charge move from point A to point B. So PD, potential difference, is the energy per unit charge as charge move from point A to point B. And like I said, that voltmeter placed across the resistors measures or gives the potential difference. So e.m.f say the total work done on charge when the charge flows around the complete circuit. This is the total work done, total work done, a unit charge, point charge flows in a complete circuit. See, so to charge, the total work done going to charge in a complete circuit is what's called e.m.f. For example, here total charge is 12 joule. This is e.m.f, and the PT here is said is 8 joule, 4 joule. Across this resistor, a PD is 8 joule, and this resistor of 10 ohm, the PD is 4 joule. This is in terms of wattage, but in terms of volts, we say here is 4. The PD is 4 volts. Then the PD is 8 volts, and the e.m.f is 12 volts. The volts of power supply is what will give the energy in a complete, or the volts in a complete circuit. In a complete circuit, that will be the e.m.f, and the volts or voltage across the resistors will be the potential difference. It will be the potential difference. The electrical resistance. Electrical resistance, which is R. This we say is in a ratio of potential difference, to the current. So electrical resistance is R, potential difference V, ratio current. So V, this is the resistance, which is V over R. So V will be equal to IR. V will be equal to IR. And so the units here, units of resistance here. Let's start by V. V is volts. The units of potential difference, volts. Say PD. Volts, and the current, units of current is ampere. So resistance is given by volts per ampere, or ohm, which is measured by this symbol, ohm. So we can define 1 ohm. What is 1 ohm? So what is ohm? From resistance equal to V, or potential difference over current. To say now, let's say we have a resistance of 1 ohm and potential difference of 1 volt, and a current of 1 ampere. So say 1 ohm is given by 1 volt per 1 ampere. So now ohm is the resistance of a component when a potential difference of 1 volt drives a current of 1 ampere through it. Is the resistance of a component when a potential difference of 1 volt drives a current of 1 ampere through it. So it means through a component, through a resistance. So that is ohm. So now let us find or solve this question. Calculate the current in a lamp given that its resistance is 15 ohm and the potential difference across its ends is 3 volts. So the given here information or data is potential difference, which is 3 volts, and resistance, which is 15 ohm. So now we can calculate the current from this question, which is R is equal to V over I. So here it will be R is equal to our volt is 3, now our okay how to find the current. Okay, so it is RV over I. Now I will be equal to V over R. V over R. V over R. So V is 3, our R is 15. So current here will be equal to 0.2 ampere. 0.2 ampere. Continuing with electrical power. Electrical power. Electrical power. So the electrical power, from definition of power, is the rate of energy transferred. Is the rate of energy transferred. Is the rate of energy transferred. So power is measured by what? Power is measured by watt or W. Power is measured by watt. So now power, we say, is energy transferred over time taken. But in electricity, energy transferred is given by potential difference times charge. Potential difference times charge. We say change in charge. Change in charge. Potential difference times change in charge. So our power, our electrical power here, will be equal to energy transferred V times charge over change in time taken. But remember that change in charge over change in time is current. Change in charge over change in time, it is current. So the electrical power will be given by VI, potential difference times current. Potential difference times current is equal to VI. So now the electrical power, say now the rate at which energy is transferred will depend in potential difference and the current. Will depend the rate of electrical power of electrical energy transferred would depend in potential difference across the component and the current in the component. So here we can from here we can continue with we can give a power in terms of resistance also. Now from V is equal to IR. V is equal to IR. So we can remove V here. So P will be equal to I square R. P will be equal to I square R. Or we can remove I. So I is equal to V over R. So here P will be equal to our power will be equal to V square over R. V square over R. Also can calculate energy, electrical energy. Another form of electrical energy. Here. Now we say power is equal to energy over time. Power is equal to energy over time. So our energy here will be equal to PT. So our P is equal to VI. Our P is equal to VI and this is T. So our energy will be equal to VIT. Or in a simple way we can say our energy is equal to ITV. This is the simple way to remember. ITV. This is time, this is potential difference, this is current. ITV. ITV. Let us see how we use the formula of power to calculate this question. Calculate the rate at which energy is transferred by 230 volts main supply, which provides a current of 8 ampere to an electric heater. So what is given here is V, which is 230 volts. What is the difference? And we have a current which is 8 ampere. So from P is equal to IV. P is equal to IV. So the rate at which energy is transferred, this is power. So our P power will be 8 times 230, which will be our power equal to 1840 watts, or in terms of kilowatt will be 1.86 kilowatts. So this is a simple way to calculate these questions by using the formulas of power.